So let's fix the motor thug, but I think because the motor thug now is at it's well, at least the first time you see him, it's very it depends a lot on where he is, or basically the battle arena, I guess, whatever you want to call it. Let's say over here we have a new phase that is going to be the boss phase. So let's duplicate this one. Let's open it up. Let's move it here. I'm going to put the trigger then. Let's see where this is. I am not seeing the trigger. Come on. Okay, so let's say boss trigger. And units, I'm simply going to keep the motor thug over here. So the idea is actually we're going to have a lot of motor thugs, not just one. And once they pass, they will vanish and they will come again, or we can have them all. Just wait at the edge of the screen until you go and hit them in. So let's take all of this and move them around here. I think this will work fine for this. So let's say about here, I guess. Now let's enable this one and let's bring the motor thug in here. Okay, so a few things that I've done off screen is for the motor thug, the dead, it looks something like this, and we're basically using a few more layers than the motor thug, as you see. Okay, so I basically just duplicated the layers, and once and only on the death animation it will not use the first sprite renderer, it will use this one. Then we have jump in, we've seen this already. The walk hit, we've seen this already. And when he's hit, he's going to do like that. Okay, then let's assign the hurt box first of all. This one. Total pivot. Okay, this one trigger. Okay, so for now, actually, I'm going to remove this from over here, and it does have and we have a motor thug animation. Okay. So let's rotate him actually. Can I rotate it like that? Let's see. Well, where is he? Oh, whoops. He was going the opposite way. And actually, I don't know what he's going to do. So let's see. He's definitely going. Okay. We have set it up, I guess. What is he even doing? So we have our waypoints and we're getting the waypoints from the okay, yeah, okay, now I understand this. Waypoints is up here, so we got them in there. Okay, so let's move them over here, and let's see, where are those? Position 1 to position 2. Yeah, I think for the most part that should work. Okay, we just have to move the waypoints a little bit below, and he just made so that he always look towards the player. That's a behavior from the different players, so we don't need to do that for this game. So let's check one thing. Let's check our AI handler again, and let's take it from the top. So on update, yeah, this should not be the case for this type of enemy. So we'll do a bool don't look at player. So if not, don't look at player. So that should fix it for this guy. Then so we get him to basically play from one end to the other, and then he immediately jumps back again, which we don't really want to do at the moment. And the question is, I think I like my idea to just have them stay on the edges, like so, like having them just so inside here. So we can use a new AI director for this. So let's think. So the motor thug, it just goes from one point and changes to the other. I'd like to have him attack. Okay, so let's create some states. Motor state, and we'll do one will be going from one waypoint to the other. Okay, we also have a wait time. Wait t speed by 4. Speed actual wait t. That's just the larping, okay. We want a wait as well. Then public float waiting time, float wait time. Now if wait time is done, doing an init again. Okay, and false tick. Current logic exit this. So the tag is just, yeah, the exit state is just follow him on that one. Okay, so the simple solution to this will be to go on here, and if it's done, we'll say if waiting time, or if wait time is higher than 0, wait time minus delta and return false. So on init, we also need to say wait time equals waiting time. We can also make this a min max wait time. So this will be random dot range min wait time max waiting time. So then he can go into something different. And okay. So we have our waypoint. We want them to be. I think it would be better to have an AI handle this guy, or when he can attack or when he cannot. So for exit states, I think we might not want to use the waypoint. Anyway, let's see how this works, and we'll think about it as we go. So let's hit play. So now he goes, he passes once and just waits for 2 seconds. And then he just resets again. And maybe he will jump in as well. Okay. So we'll make it come in, get up and stay on a new waypoint, and then we make it okay, so exit state will be motor thug wait. Actually, no. Damn it. Okay, close that. State init wait waiting time. Okay, let's create a new one, which will be motor thug wait. Yeah, it's more of a designing thing what we're doing over here, but I think it will be nice to see how we can make our own logic. Let's also bring the motor script as well. Okay, motor tag then. Wait. Okay, so in these two. So both of them are okay. It's sign state, exit state. We're going to copy this, paste this here. Then on init, we're going to want to get an AI and yeah, we kind of want to get waypoint. Okay, hold on for that. And then we're going to get this. So basically, all I want to do is just lerp him to a waypoint now that is inside the level, and if the player gets close, he will attack. Or if something so Let's take one of these. Speed actual. We want wait t, waypoint, wait t. Okay. Let's take this and then I'm going to paste this. Actually, we just want to be doing the same things, how will we? So no, I don't. Damn it. I'm kind of confused, or I kind of want to do this simply, in a simple way. So we know that you finished one state over here. Okay, so here's what we're going to do. Let's go back to this one. So thug state will be our motor state, moving, waiting, moving and waiting, and maybe we want to have something else, or attacking as well would work. So wait time. Okay, so once this is done, we want to know our current state. So public motor state, current state. Okay, from the AI handler we have our waypoints. So first of all, we need to basically get vector 3 position 1, vector 3 position 2, and replace this with position 1 and position 2, because it's all our methods that we're going to be using. There's not much point to this. So if current state equals moving, then P1 will be h.waypoints or waypoint position 1 dot position, or P2 waypoint position 2 dot position, else waypoints and I think maybe if we are not moving, so if current state equals motor state dot waiting, then we can basically hardcode the waypoint to this, or we could just say just get one of the waypoints. AI waypoints. You know what? AI waypoints. Okay, so I'm just going to do some helper utilities, I guess. Okay, let's call this. Let's delete that thug wait, we don't need it. Let's say motor director, and it's going to be similar to the AI director we have. For some reason it takes a little bit to load manuscripts. I don't understand why, but whatever. Okay, delete all of that. Okay, then I need a list of all the AI handlers. AI handlers. Then void update. Then I need a list of wait positions. And then on my AI handlers, I need a hook to my logic. So AI handler. I'm just going to assign a transform to this. Public transform, helper transform. Okay, then whenever I'm going to doing on the motor tag, whenever I'm going to statize this, I'm going to be saying position 2 will be handler.helper transform dot position, and position 1 will be the h.helper transform dot position minus or not minus, plus h.helper transform dot right by 10, something like that. Maybe 10 is too much, we'll see. By 10. So if we are waiting, it will change to this. Okay, so if wait time, then false, else if wait time actually this will always return false, like so. Yeah, so if current state is motor state dot moving, set current state to waiting. Okay, and init again, basically init h. So there's no reason to leave this state ever, so the exit doesn't matter. So okay, so waiting. Once you're waiting, you're still going to be doing the same thing. So if current state dot is waiting, then return. For now, let's just do a return. I just want to do this and see how this works. Return false. So let's hard code a method actually. Let's hard code the helper, and I'm going to assign it onto here. So let's enable gizmos first of all, and I want on my helper make this. So this guy is here. Maybe it's too good. I think I'll just put it here. Maybe that's even too close. I'll go something like this. So it from the right he will come and he will stay here probably. Okay, so let's hit play and see what he's going to do. And he vanished. But why? Oh, he vanished because he hasn't go there. Okay. So we will do waiting. Attacking will also do move to wait. So in here will be now move to wait. Wait T and waiting. Move to wait. So else if current state equals move to wait, current state equals waiting. Motor state waiting. Okay, let's see, hand rotation. We also need to do an init again. No, I think not init again, but what we do need to do is fix the rotation. Is opposite. We'll see. Random load range. What's this? Oh, that's because you do, what do you do? You rotate around the controller. Okay, so that's not the way to do this. We do this here. And hand rotation. Here we will do if h.helper transform Euler angles dot y equals 0. Actually not equal 0. So if it's rotated around, then you're going to look to the left as well. Okay, move to weight. That didn't work. So let's see why. So when you're waiting, you just return false. To wait, do this. If you're moving, just move to wait. Wait time should be 0. And wait t, do we assign this? We do assign that. Damn it. Let's say put a breakpoint to this. For some reason you're still loading. Don't understand it. Okay, let's try that again. So we are currently moving. We are changing move to wait. Then we do an init. We're getting a waypoint. The current state now is waiting. Oh, it's not waiting. Let's move to wait. Okay, my bad. Let's try that once more. Okay, waiting. Okay. That's not what we wanted. It sort of is, but it didn't work. Okay, so let's try that again. First of all, helper angles. Okay, the helper should not just change, I guess. Okay, so for this one we could just do vector 3 direction p2 minus p1 and d dot x. If it's less than 0, look to the left. Okay, let's do by 3. That's right. Vector 3 the distance, then all down here. Okay, that's kind of the Yeah, that actually changes the waypoint. So whatever I put up here don't necessarily matter. So that means we can do vector 3 start position, vector 3 target position. So, and here start position equals P1, target position equals P2, and then here let's do start position. I mean, there's no reason to do it that way. We can just say target position. Okay, so if that's the second case, then we just need to do this. If it's the first case, then P1, so if not is opposite, P2, if not is opposite, P1. And where do we handle is opposite? Over here. Okay, so let's see actually. That seemed to work. Okay, so he's just going to go and wait there. We just need to fix, of course, the movement we have. Okay, so we will move the helper to something like this. Yeah. Okay, something like this. Okay, then let's move all the waypoints then to something like this, since it's coming from either side. We need to move them a little bit more, I guess. It's kind of hard to decide with the camera, actually. Camera is a little bit annoying. Okay, but this will work. Then put that there. Then just move the helper a little bit further in, and we will see. Okay, so he can play there in idle, and while he waits there, if the player is close to him, then he can just leave off. Awesome. And maybe I'll put this back in. Okay, so the idea is now that we just take the helpers, we make a few of these, and we randomly add it to each of the players. Global, local. Okay, I think we don't use this anyway. Okay, so that's all the helpers. Let's put them over here. Then we say units. I want the AI director. Let's say motor director. AI handles, then everyone below him you can be. Let's assign an empty object as well, all the helpers. So let's think, we can create a couple of them. Like so. I think 5 of them should be enough. They all have the same helper right now, so I think we can just make it so the motor tag just, yeah. So this is what we're going to do. We're going to do weight positions right, weight positions left, then actually let's make this into lists, public list transform weight left, weight right. Okay, then we need a way to disable them. Public list integer disabled left, disabled right. We don't need this to be public, so we can make a method public transform get free position bool is left. So for actually we're going to say transform result equals null, return result. So while result equals null, then do then do for actually where do I use integer random dot range between 0 and weight left dot count, then if is left or if is right. Let's do the right first. Right, then if disabled right dot contains r, which is the index, or if it doesn't contain it, then result will be the r, then disabled right will just add the r. Disabled right not disabled right, wait, right. And we can basically do this in here as well, and we get the weight right. So so basically this will get a random index from the weight right list, and if it's not disabled, then it's going to return and you leave out the result. Now if it's left, we'll do the same thing, but weight left and weight left and disabled left and left. Okay, so that will allow him to basically get unique positions, but we need to also make use of this and clean them up. So we'll do public void clear transform, and we need to know if the transform is left or right. Of course, bool is left. So we first need to get the index. So is left, we'll do weight left dot index of, or weight right index of. Okay, then if is left, else. Disabled left, remove the index, or disabled right dot remove the index. Okay, then I'm just going to make this into a singleton because it's only one boss. and it's kind of a special boss or whatever. Okay. And perfect. Okay, so let's go to motor thug. Over here. Okay, init. Okay, so move to wait. Before you move to wait, so on init, in here we're going to say h dot helper transform equals motor director singleton get or clean motor director dot come on, get free position. We need to know if it's left or right. Where do we have that? Is opposite. We already stored it from before then. Okay. Okay, so you have a position. Then after you escape the move to wait, so when you're waiting, after you escape the waiting, then you should change, you should clear up the wait. Okay, so let's try this first of all. Each of these will have an access to our motion motor director. We don't need anything on the other, so let's populate wait left and wait right. So that will be 1 2 3 4 5 6. We got all of this. Okay, wait left, and this will be wait right. Okay, let's check this out. So let's close the gizmos and let's hit play. So they should all go find a target, and this will come here and wait, but I guess they don't because no idea, because we forgot to enable this. Okay, let's check this. Okay, that sort of works, and the is opposite is kind of wrong. Like which one they're getting is kind of wrong, but we could probably fix that. And of course, their positions, these positions should be fixed a little bit. So that would mean, although, yeah, my camera is closed. Okay. Something like that. So let's go back, and on the motor tag, when we are going the opposite way, is opposite. Are we changing that anywhere? No, we don't. When we're going the opposite way, position. Let's do the opposite one. Okay. Everyone is coming from the right, which I don't understand. But I think we are almost there. And they're coming from the right because you always have it on the right. Okay. So So we forgot to change this. Then yes, let's split them up between left and right. Because yeah, it's boring to keep doing this all the time. Left, and I think also left. Okay, and all of these are right. Okay, so all of them should be 180, and now it should work like magic. Yeah, that's actually very close to what I had in mind. Very menacing. That's pretty cool. Awesome. Okay, so only thing I'll change is the left. Let's make sure they are closer to the edge. Where are you? Let's make sure they are like around here, or maybe even like so. It's just so that, you know, they just stay on the edges and look menacing. That's the whole purpose. Okay. Perfect. Maybe I'll just make them come in a little bit closer, and then this guy also a little bit closer. Ha, awesome. That actually looks really nice. Like there's a gang that's waiting on you, and when you try to get closer, they will raise their bikes and just basically attack you. That's actually really nice. So let's see one more thing. Let's make it so when you get close to them, they will actually attack. So public float attack distance, which means once you are here, so when you're waiting, so you want to do vector3 distance h dot, or vector3 dot distance from h dot transform dot position and h dot enemy dot transform dot position. And if distance is less than the attack distance, this is a float, then you change your current state to attacking, and all you're going to want to do is false. Okay, yeah, h dot play animation or play action, not from holder. What does this do? Yeah, just plays an action from folder, but we can also do public void play action data action unit controller dot play action a. Okay, so play action. Actually, it can just be the same, to be honest. Play action from holder, because it will just force him to load the first action, I guess. Okay, so once you are in the attacking phase, we need an event that will force this to change in attacking stage, yeah. But the easiest way to do this will simply do a check. For example, float or attack state life, let's say 3 float attack state attack life. So if current state equals motor state dot attacking. If current or attack life over than 0, then return false. Else attack life minus delta. Else simply change the current state to waiting to moving actually. Init again and return false. That is okay. And attack life then over here should be attack life equals attack state life, so you can wait 3 seconds before you changing. So another thing we can do is basically force him to move to the right, but I think we can do this via, no, actually let's not do it via alert. Let's just say h.transform.position h.transform.right by speed and by delta. Let's check this out, but we do have to change the attack distance. Let's set this to 2 or to 1. Maybe 1 is too much, but we will see. Okay, so if I could get close to one of these guys, nothing happens. Okay, let's see why. Motor tag, you are in waiting. Then why are you not working? If you are here, it's transfer. Oh, first of all, let's change this to vector 2 distance, because vector 3 also has the z value which we don't need. Oops. Yeah, I don't get why you are not working. It should have worked because you are in the waiting phase. So let's see. But from what I can see, you're not even coming in here. So let's close all of the motor tags and leave only one. Then we go to his AI handler, and we do, we're not even running. Why? You are in attacking. You are attacking, but this one is not even coming here. The position that it's transform to right is what? That's fine. That's funny. I don't know. I'm lost. Let's try this with only one. And let's put some debug logs in here. So we will be saying debug log dot current state okay, he's moving to wait. He's waiting, and he basically doesn't do anything else. Moving to wait. Why? Current waiting, current state is waiting. Why you're not coming? Come on. Is he interacting? Aha, that's why. He's interacting. Damn it. Okay, so. Oops, what's this? Okay, so that was the issue. He's interacting because you were playing attack. Okay. So I think this should just go right onto the logics. I'm pretty sure of this. But for now, I'm just going to say ignore interactions. Ignore interactions. Okay, so clear that and just tick ignore directions. And he will come coming the other way though. And he goes away. Perfect. That's actually nice. Okay, we have our loop then. That's actually really cool. That's amazing. Awesome. So one small thing is we have to change. Actually, I'm not really that worried that they're not looking at the correct way. We just need to create a new animation now. We need an idle and an animation that he can basically do an attack once you run close to him. So let's see from here. You have here the transform under rotation is opposite. I'll just do this. Okay. Then let's delete the other guys and let's go fix the animations so we have the full view. So let's open up his animator. Jump in. I'm going to duplicate this one and rename this to attack from idle or just attack. Drop it in. And I don't actually care to have this loop. And I don't actually care for this to go anywhere, but it can go back to walk. It's going to be kind of similar. So let's edit the attack. You can see that it's basically going to go, it's going from up. What I'm going to do is a light, and that should go away. Layer position. I'm going to just have him start here. And we'll add some frames with this one. Yeah, so let's open this up. Let's move this out to the right, something like so, and we'll make this frame. Actually, we're just going to copy this. This is the sprite. Okay, let's start with this one. The sprite is here, so it will go like this. Maybe it needs an in between, so maybe we put this as well. Oh, maybe not. Let's take this one as his position. Okay, let's put this one. Okay, we just need the rotation to be more. There's some. Let's do it this way. So he will basically just attack like this, and he will go forward. He will be going forward for the rest of it. Okay, perfect. And let's force the attack on the AI handler. Let's see, current logic you have over here. Then the first enemy action. It's called attack 1. I don't want to make a new one just for, actually we want to make a new one for this. So let's make this motor tag. Actions, and let's just call it attack, and it's going to do a heavy thin and also spawn VFX. Why not? Then motor tag, enemy actions, then this will be motor tag action. Perfect, let's try this out. I think it's going to look really nice. Yeah, other way. If he was walking the other way, that would have been perfect. So why do we... Oh, because we are always adding on the transform dot right. So that will mean if h dot unit controller dot is looking left, do it like so, otherwise do it like so. This will be minus. Oh, this is awesome. This is really turning into something really special. Ha! Exactly. That's exactly what I had in mind. I don't like they are basically going the different ways, but fine. That's actually cool. So let's take all of our guys. Let's make a couple of them. Don't make more than there is in one side though, because that might crash Unity. So we have 6 and 6. Okay, so technically that should be fine. Somehow all of them missed me. Nice. Very nice. Now we're talking. And now we crashed. Okay, so here's the situation. We actually crashed and I have to restart, so that means I have to end the video, which is fine because we are more than an hour, but we're getting there. Before I do the restart, however, let's do one thing because we know the while was what screwed this up. So we'll do integer steps 0, and every time you're coming in here, you'll be saying, first of all, when you're coming in here, first of all, we'll be doing steps plus plus. If steps higher than the disabled left, or not disabled left, wait left dot count -1, then break the loop and just assign, I mean, if you're doing left or if you're doing right. Okay, so let's do here steps, wait left and wait right. Then you'll say, let's do force change, we'll do, oops, force change equals true, is left equals true. So if not force change, else. If it's a force change, then we simply break, and we'll do the same thing for the above. Is that equals false? So if you're down here outside of the while loop and it was a force change, then result just get an entirely random one from the right side without checking if somebody has it assigned or not. Okay, so we'll test this when I restart my PC. So I'll see you in a bit.